Unit 3.1, Lesson 2, Balancing Chemical Equations. Balanced chemical equations reflect the law of conservation of mass. The same numbers of each kind of atom are present on both sides of a balanced equation. The coefficients in front of the chemical formulas in an equation indicate the correct ratio in which the reactants combine to form the products. As a result of this lesson, you'll be able to balance a simple chemical equation and explain the role of coefficients in chemical equations. A balanced chemical equation is one that shows the true mathematical relationship between the reactants and the products in a chemical reaction. The first step in balancing chemical equations is to take an inventory of the atoms on each side. When doing the atom inventory, you use the number in front of each unit, the coefficient, as well as the subscripts in the formula for each unit. If mass is conserved, there should be identical numbers of each atom on both sides. If an imbalance is discovered, entire units of each substance are added where necessary to achieve balance. The units can be atoms, molecules, or formula units, depending on the substance present in the reaction. Consider the following example. In our example reaction, methane gas reacts with oxygen gas to produce carbon dioxide gas and water. An atom inventory of this unbalanced equation is shown in this table. On the reactant side on the left, we have 1 carbon, 4 hydrogens, and 2 oxygens. On the product side, we have 1 carbon as well, however we only have 2 hydrogens and 3 oxygens. To balance the equation, the product side needs more hydrogen atoms. This can be done only by adding water molecules to the product side. Adding a coefficient of 2 doubles the amount of water molecules. Now the hydrogen atoms are balanced, but the oxygen atoms are still unbalanced, as shown in this inventory. Adding an oxygen molecule to the reactant side will balance the equation. Adding a coefficient of 2 to the oxygen molecule on the reactant side doubles the units of oxygen molecules. Now the inventory shows that the number and types of atoms on both sides of the reaction equation are balanced. Balancing by inspection might have to proceed back and forth until the equation has the same number of each type of atom on both sides of the equation. Don't forget, every time you change a coefficient, go back and take an inventory one more time to make sure that everything is still in balance. There are 2 types of numbers in a chemical equation: coefficients and subscripts. A coefficient, like a number in a recipe, indicates how many of each ingredient can go together to make the products without having anything left over. Coefficients are the numbers you can change when you balance an equation. The subscript number is a part of the chemical formula and is not altered in balancing equations. The coefficients in a chemical equation indicate how many units of an element or a compound you have. When there is no coefficient, it is understood that there is 1 unit. Note that the coefficients can represent any counting unit. For instance, the equation on your discussion note page can show you that 1 propane molecule will react with 5 oxygen molecules to produce 3 carbon dioxide molecules and 4 water molecules. It can also show the number of moles of each reactant and product. 1 mole of propane reacts with 5 moles of oxygen to produce 3 moles of carbon dioxide and 4 moles of water. Don't know what a mole is yet? Don't worry, we're going to be covering that in our next unit. So to wrap up this lesson, how do you balance atoms in a chemical equation? We need to balance atoms in chemical equations in order to show that matter is conserved. To do that, the number of atoms on both sides of a chemical equation must be equal. However, this is done only by adjusting the coefficients of the reactants and the products. When a chemical equation is balanced, those coefficients then indicate how many molecules or moles of each substance take part in a reaction and how many molecules or moles of the products are formed.